this for some outtakes.
Outtakes.
The bloopers.
Right on.
The blooper reel. Do you want to be able to see ourselves, or is that weird? Because I can minimize this. No, I think it's kind of nice.
Coming to you from Charlottesville, Virginia, Willow Talk. With your hosts, Andrew Carter and Ben Fry. Today's topic, REST. With special guest, Tyler Romeo.
All right, everybody good?
Yeah, man.
All right. Welcome to today's vlog of the Willow Talk. Today we have a special guest, like we said we would have last time, and that special guest is Tyler Romeo.
That's it.
I forgot his last name one time, and he had to give me a hint, but I remembered at some point. And we've got Ben Fry here as always. What are we talking about today, Tyler?
Today we're going to talk about REST and what that means and how to make a REST API.
Is that like when you're at work and you're tired and you've got to take a nap?
Yeah, so the rest of the podcast is just going to be us napping right here.
I would actually like a nap podcast.
Yeah. REST stands for Representational State Transfer. And so what it is it's a way to make your web service API that's got consistent rules. And if you make something REST, then there's going to be libraries that can consume it. There's going to be people who already understand how it works. It's one of those standards that's not like formalized, but it's pretty good, and a lot of people understand what it is.
Is it always web traffic? REST?
Yeah, it doesn't have to be, but like 99% of the times you see REST, it's on the web.
What do you do? So, like, if you're going to use REST, is there like a is it server side and client side? How does that work?
Yeah, so if you've got a server that's got a REST API on it, it's going to expose some HTTP URLs. So like www.api.andrew.com /stuff, right? That's an endpoint. That's a URL. Mm-hmm. And you call that and you get some part of the data back. You get all of Andrew's stuff. And it's probably JSON, but it doesn't have to be JSON. Most of the REST you see is JSON.
So you can use XML or whatever format you want. So what makes that REST, like, getting any URL endpoint, like why is this one REST and other ones aren't? What makes REST special or different?
So REST has something to do with representing all of your data as resources. So you're going to use nouns to name things. You're going to say URL /Andrew's stuff, not URL /get stuff or like delete stuff. Everything is named by a noun, and you decide what you do with it through the HTTP verbs. So that's get, post, put, delete. There's a bunch more, right? There's options, and there's ones no one ever uses, but you just use get, put, post, and delete. Those are the only ones that really matter.
So when you're implementing this on the server or on the client, is there a standard library you use to make that happen on both ends, or is it kind of up to the developer to do that themselves or find their own way to do it?
There's libraries that will do it for you. So for Java, you've got REST-easy and JAX-RS. There's a lot of ways to do it. And then on your client, like on Android, you can use Retrofit to consume it. Is there an iOS library to consume REST?
We've got like people like AF Networking a whole lot, but they're never really REST specific, but they're kind of, because that's what everybody uses these days, they're sort of tailored to that to make it work easier for that.
So if you've got a REST API, there are libraries that help, but they aren't going to do everything for you.
So it sounds like REST is like a protocol or a formalization of way to talk to each other, and not really a piece of software. So you could kind of, it doesn't matter what backend you're using as far as like storage. It could be MongoDB, it could be SQL, whatever. It's just it's like a protocol, like how to talk to each other, right?
Yeah, exactly. And it's less formalized than say SOAP or like protocol buffers or something like that. But there's still a set of rules that you should follow, but you have the freedom to get rid of those rules if you've got an exception.
Would you say that's why it's become a bit more pervasive than SOAP, because it's less formalized? Or?
That, and it's easy for a human to read. So you can go into your browser and you can type in a URL for REST API, and that'll do GET because it's a web browser. And you're just going to see in the response that JSON right there, and it's easy to understand what's coming back. You don't have to, have your SOAP unmarshaller generate some classes for you and pull it into memory and do all this extra crap.
Have you ever actually used SOAP before?
Oh, totally.
I've heard horror stories, but I've never had to use it myself.
So SOAP works is you have a document called a WSDL, Web Service Definition L. L stands for something. And you have to generate some data based on the WSDL, and that defines every single one of your endpoints and all that they can put out, and you have to teach it how to parse based on that, and it's a lot of extra stuff.
So that's actually interesting. So you have SOAP, you have REST. What are some other big players out there for this kind of communication? Like protocol buffers, you said?
Protocol buffers, that's the one Google made, and that's technically not a like spec. It's a communication standard. So you could it's like JSON or XML. You could use a REST API that uses protocol buffers for its data. Another big one out there is claim you're REST, but you're really not, which is where you've got HTTP calls that return JSON, but it's just whatever crap they decide.
That's actually that's interesting. I think that's everyone that I talk to, it's always you've got a REST API. This you have a REST API, and then you always hear people say, but actually it's not really a REST API. So what is that? Can something be like halfway REST and halfway not REST? Or like what's a good example of things with REST people commonly mess up or?
So if you've got a REST call that's like get workflow or start workflow and then add something and it's carrying state in between everything, then that's not RESTful.
Okay.
Because you've got something in between every call. The server's thinking, all right, I just heard this. I got to wait for something else.
Okay.
The benefit of REST is that every part of your state is contained in the request. So you can make the same calls over and over again. It doesn't matter what order they're in.
Right.
That's actually an important concept of REST called, all right, it's this word right here, idempotent.
Nice.
We'll flash that on the screen. Put that in post.
We'll make it happen.
This word. Call is idempotent if you can make it as many times as you want, and the end state of the server will be the same as if you called it once.
So that's interesting. So if I've got a resource like a person resource, and I knew it so let's say I wanted to update the person and have their name be Andrew, that would be a put.
You'd use a put.
So it'd be a put. Maybe it's like people / an ID or something.
Yeah, it'll be
and
people
then
/ Andrew /1 or whatever your ID number is.
And then I would, so if I sent to change my last name to Carter multiple times in a row, that's fine because all the state's just there on the server.
Yeah, it would say change it to Carter, and it would say, all right, still Carter.
Right.
Yep, I'm good.
Does order of operations matter in REST? I guess it would if I wanted to do a create and then an update if they came in the wrong order.
Sure, order matters in with respect to data. You can't update something that doesn't exist yet, or if 2 updates come in, then you're going to apply one, then apply the other. However, you don't want to have a necessary order of your calls to go through a workflow or something.
Okay.
So you can't say, well, I can't call, get work right now because I haven't set up my stops yet, and work needs stops in order to operate. Yeah.
Okay. What are some popular REST APIs out there right now? If I wanted to go look at some and play with some and get more familiar with it.
GitHub is really good. Twitter is pretty good, although they've got some pretty strict authentication thing you have to do.
Right. That's it. So does authentication matter with REST?
Is
there a built-in way people usually do it with REST, or?
You'll typically see OAuth, but it doesn't really matter. And then authentication is actually a good thing to talk about because when you're authenticating, you've got to authenticate first before you get anything, right? Otherwise, there's no point to logging in. So authentication is a good exception to this rule of everything stateless. You are going to want to log in first and get some kind of token or identifier so that you can make the other requests.
That's it. So like in the Facebook API, there's the get me, and I guess that's kind of, there's some state there because the server knows who you are based off your authentication tokens. So does that break REST, or is that just
it's
gray
not
area?
Pure, it's a gray area, but that's an exception that's kind of okay to make, and a lot of APIs you see will do that.
So if I want to write an API that uses REST, you mentioned there are some tools that make it easier. So I'm familiar with Rails or Django, and I guess those things are built to aid you in making a kind of REST environment.
Yeah.
But I guess is it still possible to kind of abuse the way the system's set up to make it not quite what's a good example of an endpoint that would seem RESTful but actually isn't?
Oh, totally. So let's say you're making an API for racing, right?
Okay.
And you put in every single person's everyone's coming into the race, and then for every single one of those people, you say, all right, I'm going to call start race. I'm going to call Andrew /start race, and then Ben /start race, and then when they're done, I'm going to call finish race, and then it's going to have timed all of them. That's not really RESTful because you've got state on the server,
right?
You're currently timing someone right now.
That makes sense. So how would you fix that? Would you maybe for each racer call here's what time they started, or then call here's what time they. So it'd be a put, I guess, to update those fields.
I'd say you'd give each racer a list of races that they've been in, and then you'd say, all right, let's make this new race, and the start time's this, And then when they have an end time, you would do a put on that race and say, all right, we're updating the end time. And then you can do logic somewhere else to figure out what the elapsed time is, because that's what you really want. But you've represented your data in a way that's going to be more flexible, because maybe later on you want to compare like the names of racers or something.
Right.
And
okay.
that's not going to work with your other way you set it up. Yeah.
That's interesting. What about like how do filters come into all this? Like you mentioned the race. Like, what if I wanted to know like what was Andrew's best race that he ever did? Like,
Sure.
is that usually client side logic where he just gets everything and does it himself, or is it part of the standard? Do I have can you pass like a Google OData filter kind of thing?
You can do it either way. The most common way to filter data would be to set up your API with query parameters. So you'd say get racer / Andrew, and then add a query param for sort best time, and that would return your best times first, so you can see it that way. Or maybe filter times less than 2 minutes. You can run a 5K in less than 2 minutes, right?
Oh yeah, definitely.
Totally.
I've been practicing.
But you got to be careful, because you want everything to be in the request. No matter who calls, Andrew less than 2 minutes is going to get the same data.
Okay.
Now, let's say we made an API for our Pokemon, right?
All right.
So I call, API / Pokemon / Pikachu. And it shows me, all right, he's electric type, it's got all this. And maybe you think, well, I want to know if I've caught it, so I'm going to put is caught in there, right? Nope. The problem with that is that data is tied to me.
Okay.
So whether or not it is caught, it's different if you call it or if I call it.
Right.
And because that data is different, it can't be cached. So what you'd want to do is represent like a person, and they could have a list of all the ones they've caught.
Okay.
Instead of putting that in the Pokemon, in the Pikachu object, because
that makes sense. So you want the object to be the same. So like the Pikachu should be the same for everybody. But if you wanted to know which, I guess you are a different entity of a person. So if you call Andrew, no matter who calls it, I'll have the same Pokemon.
Right.
And you want it that way so that you can cache it for quicker querying in the future.
So we've been talking about all these rules just because, like, these are the rules. That's what they are.
Yeah.
So let's talk about, like, why they're good.
Okay. That's a good point.
So if you've got, like we talked about, it makes data easier to cache. So you can put middleware on your server that caches your responses. That's going to make your server faster. And because it's stateless, you've got an issue where a ton of requests are coming in. You just build more API servers, put up 100 of them behind a load balancer. And since there's no state on your actual app server, it doesn't matter who gets the next request. You just send it to someone and it'll be able to handle it.
Right.
Yeah.
So it's pretty easy to scale.
Yeah, it's a lot easier to scale a stateless web service than it is something with state.
Do you know how long like REST has been like the thing, or the
You're going to make me look something up, aren't you?
Yeah. I'm curious. Let's look it up.
It's been around since... So according to Wikipedia, it's been around forever.
Sounds right.
Oh, no. According to the third paragraph in Wikipedia, Roy Thomas Fielding invented it in 2000. So that's pretty good time, time ago.
Yeah, pretty long time ago, but still, I guess, relatively new.
Mm-hmm.
But
So you said you can load balance a lot easier because it's stateless. But you have putting and posting and whatnot. Does that not run into an issue for, like, if somebody's posting to one server and then another one gets the GET request from somebody else?
So you would have different layers. So your persistence layer, your database, that would be all self-contained. And then you've got multiple layers that are doing the routing and request logic. So no matter which API server you hit, you're going to call the same database to get your data out. But it doesn't matter which one gets it, because there's not it's not remembering in memory, oh, I've got to handle this guy's request this way, yes, because there's his J session ID or something like that.
So what are the are there any downsides to REST? Like I know with I think the good thing with SOAP was supposed to be that like part of that document would describe like maybe validation rules, or here's how to parse it, or here's where to look for different things. And I know XML, like I guess you can use XML for REST, but you don't see it usually. But there's like XML can be more specific about just different rules on how to consume the data.
Right.
How does that work out with REST?
So with REST, it's a lot more freedom. It's kind of like strict typing versus weak typing, right? There's freedom, but you've got to be disciplined. If someone's making your API and they decide, I'm going to change the name of this field, everyone who's consuming that API better find out quick, because it's going to break their stuff. They can't parse it anymore.
So how do you, if I need to change, like if I need to add a field or remove a field or change an entity, what's like, how do you got production apps out there, people are using, how do you fix that?
I would leave your production apps up and make a new endpoint under like /v1 or /v2 and add some stuff. then you send out an email to everyone that says, hey, here's V2. I'm giving you a year to switch over, and then I'm going to turn this off. That's what Twitter did with their V2 one.
Right.
Is they gave everyone a year, might have been a year and a half to switch over.
Mm-hmm. So I guess now I was about to ask you if most REST APIs were free to consume, like Twitter. But I guess that's kind of it's almost like using the word REST wrong, right? Because just because it's an API doesn't mean that it's REST.
Yeah, are most APIs free? Maybe. Some of them are free, some cost money. Like the Forecast.io costs money, GitHub is free. It just depends on that company's business.
Sure. So, and one other thing I wanted to kind of mention is that we've been doing a bit of work with some SAP things and some clients that have some older infrastructure. And I've been seeing lots of people putting new like REST layers on top of older technology. What are the challenges of doing that? I mean, it makes it easier for the clients that are going to consume that because it's the more up-to-date, easier thing that people are used to.
Right.
But like now you've got another layer on top of other layers probably. So how does that, is that a good idea usually, or is it better to start over from scratch, or what's a good strategy there?
It really depends. If you've got, a mobile app or something that needs to consume data, you have to have a more modern format. A mobile app can't open a DB connection to Sybase or DB2 or something. So if you really need to keep your old database, then you're going to need a middle layer in there. But if you've got the freedom to migrate to a new database, might as well do something else and not have that technical debt to deal with.
Right.
So it depends on the project. REST is a tool you have whether you decide to use it or not.
Oh, one other thing. How do you? So, let's say that I'm using the REST API and I do something wrong. Like I hit an endpoint that doesn't exist, or try to perform an operation that I can't do. What's the way of communicating back and forth with the client? Like you can't do that, or you shouldn't do it this way, or is there a standard for communicating problems back and forth?
Yeah, the HTTP codes. There's a whole list of them. 200 means okay. 404 means not found. REST is supposed to use all of those. So basically, the way I think of it is anything in the 200 level means you're good. Anything in the 300 level means something moved. 400 means you, the client, messed up.
Right.
And you need to fix your request.
Okay.
And 500 means me, the server, messed up. My bad. I'm going to try and fix this.
Right.
It's been reported to Frank, who's going to go and read the logs and figure out what we did wrong.
That's cool. Okay.
409 means access denied or something.
Also a good Beach Boys song, I think.
A cleaning product.
Yeah. Do you have anything else, Tom?
Well, let's talk more about cleaning products. No, that's about it. That's REST.
Awesome. Ben?
Cool.
You in good shape?
Yeah.
All right. Well, that was REST APIs. If you have any questions, feel free to comment on our YouTube video page, and Tyler will answer all of them immediately. And we'll look forward to seeing you guys next time, and that's Big 10-4.